Hello friends. Now let us conclude this chapter of rest and motion kinematics with the final topic of the subject, relative motion. So far we have tried to describe and understand motion based on one fixed frame of reference. Okay, and we know that acceleration, velocity, position vector all depend on the frame of reference chosen. Now, what happens if we have two frame of references? Can we relate the acceleration, position vector and velocity in these two frame of references? So this is a very important topic. So let us say we have one frame of reference which I call S. Okay, so it has an origin O here, and I have another frame of reference which I call S prime and which has origin here. Okay, and this S and S prime are moving translationally with respect to each other. Okay, so here the assumption is their relative velocity is small. Okay, and second, there is no rotational motion happening in the frames. Okay, so there is only translational motion that is happening. So let us analyze a point P here. Okay, so from the frame of reference of S, the position vector for this is RP with respect to S, which is OP. The position vector of P with respect to frame S prime is O prime P, which is RP S prime, and the position vector of O prime, which is the position of frame 2 or frame S prime with respect to frame S, is OO prime. Okay, which I call R S prime with respect to S. Okay, so now if you see, we can say OP is equal to OO prime plus O prime P. Okay, so this is by the simple triangle rule of vector addition. Okay, so this means OP, or the position vector of R of particle P with respect to the frame S, is given by the position vector of P with respect to S prime plus position vector of S prime with respect to S. Okay. Now, if I differentiate with respect to time this equation, I get V velocity of P with respect to S is equal to velocity of P with respect to S prime plus velocity of S prime with respect to S. Okay. So this gives us a very handy and useful equations for position vector and velocity, how they are related in moving frames. Okay, so by using this I can say V of P with respect to S prime is equal to V of the body with respect to S minus V S prime S. So that means that if I have the velocities of two bodies with respect to one common frame, I can find out the velocity of one body with respect to the other body. Okay, or if I state this simply, velocity of first body with respect to the second body is given by velocity of first body with respect to ground. Let's say if I consider my first frame of reference as ground minus velocity of second body with respect to ground. Okay, so we have many problems based on this very important principle of relative motion or relative velocity. So let us try to understand this by understanding an example. Okay, so let's say my swimming velocity with respect to still water is 5 kilometers. Okay, and let's say when I go to a river to swim, the water itself, the down current is 5 kilometers per hour. So that means that if a person is sitting on the ground and if I start swimming, if I am swimming towards the current, so my velocity is 5 kilometer per hour and the current's velocity is, so velocity of swimmer with respect to river is 5 kilometers per hour. Velocity of river with respect to ground is also 5 kilometers per hour. So that means to a person on the ground, so that means a person on the ground, so velocity of swimmer with respect to ground becomes velocity of swimmer with respect to river plus velocity of river with respect to ground. And of course, all of them are in the same direction. So I can say velocity of swimmer with respect to ground is equal to 5 plus 5 is equal to 10 kilometers per hour. So a person on the ground will see me swimming in the downstream with a velocity 10 kilometers per hour. And what will happen if I swim opposite to the current? Let's say my velocity is 5 kilometers per hour downstream, but the current is in this direction, 5 kilometers per hour. Okay, so velocity of swimmer with respect to river and velocity of river with respect to ground. So what happens in this case? So I am trying to swim upstream, okay, but the velocity of swimmer with respect to ground is equal to velocity of swimmer with respect to river plus velocity of river with respect to ground. So of course this is all in the same direction. So I can say velocity of swimmer with respect to ground becomes 5 plus minus 5. So this is equal to 0. So that means with respect to ground, I am not moving at all. Okay. So now let us try to solve one simple problem from this book, HCV Verma, which is question number 3.10. Okay. So let me erase this part here. So let us solve this question. A swimmer can swim in still water at a rate of 4 kilometers per hour. If he swims in a river flowing at 3 kilometers per hour and keeps direction with respect to river perpendicular to the current, find his velocity with respect to the ground. So what the book is saying is, so this is example 3.10. So a swimmer is trying to swim perpendicular to the river, okay, with a velocity of 4 kilometers per hour. So velocity of swimmer with respect to river is 4 kilometers per hour. But the river itself is flowing. So velocity of river with respect to ground is 3 kilometers per hour. Okay. So what will be his velocity with respect to the ground? So now we can use this equation. So velocity of swimmer with respect to ground is equal to velocity of river with respect to ground plus velocity of swimmer with respect to river. Okay, so I know, so we know both of this. Okay, but direction is perpendicular to the flow. So what will be the resultant of these two? So this is a vector sum of this and this. So this will be like this. Simple. Okay, so let's say this angle is theta. So we know what will be, so this is VSG. Okay, so mod of VSG is equal to, this is the hypotenuse of this triangle here, so this will be 4 square plus 3 square under root, so this comes to be 5, so 5 kilometers per hour. So the velocity of the swimmer with respect to ground, the modulus of that or the magnitude will be 5 kilometers per hour, and in which direction? It will be at an angle of tan theta is equal to 3 by 4 from the vertical. So that's how we make use of this relative velocities concept.